This is Clever Hans, a horse famous throughout Germany in the early 20th century. He could add, subtract, multiply and divide, distinguish colors, recognize coin denominations, point to the correct time and dates on a calendar, and answer both spoken and written questions by tapping his hoof the correct number of times. It seemed that Hans truly understood everything. His skills were so astonishing that a special commission was formed to investigate this phenomenon. Surprisingly, no fraud was found. Even when his owner wasn't present, Hans could answer strangers' questions correctly almost 90% of the time. So how did he manage to do it? It turned out that Hans could only solve problems if he could see the examiner and if the person knew the answer. After each tap on his hoof, Hans closely watched the person's reaction. When the number of taps matched the correct answer, people would slightly adjust their posture, facial expression or body language. Hans was incredibly sensitive at the subtle changes and would stop tapping at the correct answer. Essentially, he was just an ordinary horse, but with one exceptional skill. Unfortunately, though, no unique intellect was uncovered. But thanks to Hans, we know that people who know the correct answer, even if they're only observing, will reveal it through emotions, expressions, or other weak signals. In psychology, this is now called Clever Hans effect. It's impressive but explainable. After all, we understand we can subconsciously influence people and animals, and vice versa. And you might ask, what does it have to do with quantum immortality? To understand the concept of quantum immortality, we'll have to revisit Schrödinger's cat. Many of you might be familiar with this thought experiment, and if so, just imagine you're hearing it for the first time. Here is the essence of Schrödinger's experiment. A cat is placed inside a sealed steel box along with a small amount of radioactive material, a Geiger counter, which measures radiation, and a hammer connected to the device. Below the hammer sits a flask containing lethal chemical. Here's how it works. Radioactive decay is a random process that cannot be predicted, which means there is a 50-50% chance whether it will decay or not. If it does, then the Geiger counter will detect it, which will trigger the hammer to smash the flask that will release the chemical and eventually killing the cat. If no decay occurs, then the cat is happy and remains unharmed. Since we have no way of knowing if the Geiger counter has detected radiation without opening the box, then we don't know for sure what happened with the cat. So the cat is both alive and dead at the same time. But don't worry, this was purely a thought experiment proposed back in 1935 by Austrian physicist Erwin Schrödinger. Alright, you might think you've heard about Schrödinger's cat before, but here is the twist. It wasn't just any experiment, it was a defining moment in development of quantum mechanics. While researching this video, I realized there are multiple worlds to consider in science, such as microworld, macroworld, and megaworld. Macroworld is the world we live in. This is my phone, my book, the house we live in, basically everything we see and touch. A scale up, the megaworld consists of planets, solar system, galaxies, basically all the giant cosmic objects. But the microworld, the smallest one, is where we find the molecules, atoms, particles, basically very small things. In macroworld, our world, everything can be explained by classical mechanics. Newton laws applies and just basic classical physics. But in the smaller world, this doesn't happen. It's a complete mayhem, and this is where things starts to get interesting. We live our everyday lives quietly, watching cars drive by and airplanes fly overhead, and we tend to think that the laws of physics we know apply everywhere. When classical physics falls short, we often dismiss it as some mysticism or something beyond our understanding. But here's the twist. Quantum mechanics steps in to explain what's actually happening there. When we realize that the happenings in the quantum world are scientifically validated, it can leave us amazed and, frankly, puzzled. In quantum mechanics, Everything exists in superposition. What does it mean? Here is a book, and here is a phone. You can see it. There is nothing extraordinary about it. Now imagine my room is a quantum system, and the book doesn't lie here without purpose. It is in a superposition, which means it exists in multiple states at once. It's lying here, hanging there, and positioned in other spots, all at the same time. It is hard for us to imagine that one object can be in two places at the same time. But as I said earlier, in quantum world, the laws are completely different. But in the microworld, instead of phone and book, we're dealing with photons, electrons, and particles even smaller than atoms. And what happens there often feels like complete chaos. As humans, we don't really like the idea of superposition. We want to know exactly where are these particles. We want to pinpoint their true position. But here is the strange part. The moment we try to do that, the superposition disappears, and we're just left with one book in the room. It may sound a bit ridiculous, but when we try to check or change something in the quantum mechanic world, all the mystery seems to vanish. These particles are so small and so sensitive that just by measuring them, we disturb their natural state. I didn't understand this at first either. Let me try to break it down for you. We have a pool table with balls on it. One ball hits another, and we want to capture the trajectory. We take a camera and snap a photo of the balls as they roll. There will be photons that come out of the camera light. These photons hit the surface of the balls, but they're too small to have any noticeable effect, which is why the balls are hardly affected by them. Now, imagine the balls are replaced with photons, which we want to capture. We take the same camera and fire photons at other photons. They collide, and since they're roughly the same size, their trajectory change. It's impossible to measure something in the microworld without interfering. Imagine taking a photo of a pool ball, but as you do, millions of other balls fly out of the camera. That's roughly what it's like. In short, observing the microworld changes it. We don't capture the object itself, but rather what our observation does to it. So what is the observation in the first place? This question has intrigued me for a long time. Right now, I'm looking at the camera while you're watching me through your screen. But in the quantum mechanics, it's different. I remember watching a science series with Morgan Freeman. He explained that when we observe a photon, we change its trajectory just by looking at it. He even suggested that reality isn't fixed, it's altered by us because we observe it. He based this on the famous experiment with two slits, which you can see on your screen now. Here's how it works. If we shine a beam of light through these two slits, photons act as a wave, creating a pattern of interference. At first glance, it seems completely illogical, but as soon as we try to observe which slit the photons go through, the wave interference disappears and we get a predictable outcome. When we stop observing, the interference pattern returns. So what does observation mean in quantum mechanics? It doesn't necessarily require human intelligence. It could be any device that detects photons or other particles. But that act of detection inevitably affects tiny objects in the microworld. This leads to a major question. How can one object be in multiple states at the same time? It's a crucial question, and we don't yet have a definitive answer. Scientists have multiple interpretations of quantum mechanics, but keep in mind, these are only hypotheses to explain a strange reality. One well-known explanation is the Copenhagen interpretation of quantum mechanics. Proposed in 1927 by Danish physicist Niels Bohr and German physicist Werner Heisenberg, this interpretation suggests that objects in the microworld can exist in multiple states at the same time. But the moment we measure them, we force one of those states to be realized, and all other possibilities disappear. Many people stick to the Copenhagen interpretation, but personally, I think the many world is much more intriguing. In 1957, American physicist Hugh Everett proposed this idea. According to the many world interpretation, when we measure something in the microworld, the universe splits into two or more identical universes, and we find ourselves in one randomly chosen outcome. It's as if the world has doubled. Now there is a scientist who measured the photon and the entire universe followed that path. But there is also another universe where the scientists observe a different outcome, leading to an entirely different world. Does it sound like nonsense? Well, in reality, many scientists support this interpretation. The many world even opens up a strange concept known as quantum immortality. Remember Schrödinger's cat? We don't know if it's alive or dead until we open the box. But now, let's imagine a person in the place of a cat, in a similar chamber. Here is the scenario. A gun is aimed at the person, and it will either fire or not. If the Copenhagen interpretation is correct, and the gun fires, the person dies. But if the manual world interpretation is right, then each time the trigger is pulled, the universe splits. In one universe, the person dies, and in the other, they survive. Here is the paradox. Imagine you're that person in the chamber. Every time the gun fires, you survive. How? Because you only observe the experiment from the universe where you're still alive. So in theory, you're quantum immortal. You'll never be able to experience your own death, only the versions where you survive. Now, let's be clear. This is not an experiment anyone should try. No one has tested this idea and it's likely impossible to carry out. You always survive. Everything is great in your universe. But what will other scientists discover when they open the chamber? Okay, I am sure you will agree that this is interesting. You will never cease to exist. There will always be something that will save your life and make you immortal. And all of that may be true. It should be understood that scientists don't agree on one interpretation of how it all works. If you're really interested in this subject, research it yourself and check out the links in the description. I'm sure scientists will figure it out someday. What matters is that it all works. Thanks to quantum mechanics, we have such cool things as... Actually, let's talk about it next time. Thanks for watching.